Dan Casey, Manufacturing Manager for the Tolling Division at Penn United Technologies. When I first started here 28 years ago, I had no idea that my career would lead to this, being in charge of the Tolling Division. Actually, I didn't know anything about manufacturing, stamping, dies, machining in general whenever I started here. I was working in retail. My father and I had our own sporting goods business, and it was a lot of fun. Got to spend a lot of time with my dad during that period of time, during my teenage years, and it was just a good time. So fast forward a little bit, I graduated from Butler High School, and it was time to do some things with my life. So I went to community college for 2 years and got my associate's degree in business administration. After that, I had plans to get married. I wanted to marry my high school sweetheart. So our store at the time, it was doing pretty well for us as a family, but to support two families, it just didn't seem like it was going to be enough. So I started to look for employment elsewhere. I did a little stint at Eaton Park Restaurants as an assistant manager and used some of the business background that I got from going to BC3. While I was looking for a long-term career, a neighbor of mine suggested Penn United Technologies Apprenticeship program for the tool and die. And I wasn't sure what it was, so after he explained to me everything about the program, it just sounded like a really, really good fit for what I like to do. So Penn United offers a number of different apprenticeships, not just tool and die maker. We have plating, we have carbide technicians, we have machinists, grinders. There's a number of them. I chose the tool and die maker apprenticeship. And the thing that I liked most about the apprenticeship, that appealed to me most, was the fact that it's a 4-year program. And at the end of the 4 years, you are already placed in your career, where trade schools are great and they have a lot of opportunities for people. But sometimes there's placement issues, things like that. So at the end of apprenticeship, you've been paid the whole 4 years while you were working, and then not only do you have a job when you're done, there aren't student loans or anything like that to pay back, and that's a very big plus. We build progressive stamping dies for a number of industries: automotive, electrical connectivity, energy, gas and oil, and medical, just like this item that is used in a surgical stapler. This is an example of a progressive stamping die. It's termed progressive because things happen in a progression in stages. We're not able to stamp the completed part all in one hit. The amount of force that it would take to do that would be too much. So we break it down into components. We might cut some cavities or a hole or do a form all in different stations. And then we have the finished product at the end.
Here we have the Minster P2H, a 100-ton precision straight-side press with an adjustable rate. This machine produces 220 parts per minute. Running the Minster P2H is Greg Claypool, press technician from the production stamping team.
So this process is sync EDM, electrical discharge machining. What we're doing is using an electrical current to actually machine or erode the material. It's very, very good for, or it works very well for machining carbide and steel. It can be used for anything that's conductive. So this carbide detail is a multi-pierce die section for a bearing retainer. So we make these bearing retainers for roller bearings, and to cut all the windows for the bearings, we use wire cut technology to cut those cavities to the right size and to the right location. So what we're getting ready to do on our wire EDM machine is cut cavities through this die bushing. It starts with a set of start holes for the wire to feed down through. Then the program runs the geometry that's entered into it and cuts our cavity through. So we're getting ready to cut this die bushing with our wire EDM machine. We start with a set of start holes that the wire will feed down through. Once it's fed, our program will run and the die bushing will get the cavities that we'd like cut to the proper geometry. This bushing, it acts like the bottom part, say, of a hole punch, where you have the punches through the paper into the bottom cavity that actually cuts the paper. This cavity is going to cut the steel into that shape.
While the wire EDM machine is running, it's constantly feeding fresh wire through that cavity that it's cutting. That must happen in order to maintain size of the feature that you're cutting. If the wire wears, then the size of the cavity will change. So you're constantly feeding new precision size wire through that cavity to maintain the size of the cavity. This is a precision jig grinder. A precision jig grinder is a machine used for grinding precise holes in complex contours where the highest degree of accuracy and finish are required. This machine has a tool changer so we can run lights out with certain jobs that run on this machine. This component is something Penn United worked on a while back. This is the reader head for the hard drive in a computer. A closer look under a microscope, you will see many small features, small holes. The precision that's involved with that reader head, the closer they can get that to the disk, the faster it's going to read. The tolerances they worked to when building dies for these components were just phenomenal. What started in 1971 as a small tool and die shop on the Jones family farm near Saxonburg, PA, machinists Carl Jones, Robert Becker, and Charles Barton laid the foundation that would support Penn United Technologies Inc. throughout the years.